Um, Hello everyone. Should we start? Nishant, Alka, Priyanka, should we start? Okay. So I'm Jyoti Sharma. Here is my brief introduction. I'm right now a PhD student, and I had my MSc from Environment Management from Research Institute Dehradun, and BSc from Botany Honors from University of Delhi. Uh, then okay, so how we will proceed? So I have a lots of multiple type questions, and we will try to solve it with lots of discussion. And I encourage you people to discuss, and your participation is highly valued. So I have MCQs, and whenever you think that the question is not very much clarified by me, then you can raise your hand and you can ask me. You can interrupt me anytime. So let's start with it. So I have first question, and the first question is atmospheric stability is associated with the, and this is the filling the blanks, and I have four options. The first is temperature profile, the second is pressure profile, the third is relative humidity profile, and the fourth is rainfall profile. So I have created the poll, and you can answer it accordingly. Uh, Priyanka already gave me the answer A. Okay. Yes, more. I'm expecting more. Alka also gave me the answer A. Yes. Okay. So exactly your answer should be A. And why this is, I have some background slides so that your queries will be cleared by this. So okay, because the question was related to the atmospheric stability. First, you should know what do you mean by the atmospheric stability. If you people are if it is unable to you people to understand, you people can convey this message to me. I will try to clarify it further, right? So, what do you mean by this atmospheric stability? This is nothing. This is just the tendency of the atmosphere either to resist the motion of air parcel, or to give it a like rise to the air parcel in a vertical motion. So for example, you have atmosphere, and in atmosphere you have air parcel, let's say from the chimneys. So how this air parcel that has been emitted from the chimney will rise. So it will dependent upon the environment that we have and the some property of this plume. Okay. So whether this environment will lead to the rise of the air parcel or not. So this tendency of the atmosphere is known as the atmospheric stability, and it is dependent on two things. The first thing is how our atmosphere is behaving. For example, our atmosphere is cooling or warming conditions we have in the atmosphere, and the second is the air parcel we have, either it is warmed or cooler as comparison to the atmosphere. Okay, so we have two things that we have to keep in mind. First, the atmosphere temperature, the second is air parcel temperature. And because we know that with the height our temperature will be decreasing, and this is nothing but the lapse rate. So the lapse rate of the environment and the lapse rate of the air parcel. So we will compare these two things and we will try to find out the atmospheric stability. Okay, so we have atmosphere, we have the air parcel. For this atmosphere, we have the lapse rate, that is the environment lapse rate. For the air parcel, we have the lapse rate, that may be the dry adiabatic lapse rate or the wet adiabatic lapse rate. And we will try to compare it to let us know whether our air parcel will rise or not. Okay, so this atmospheric stability can be classified based on three things. The first is lapse rate, as we discussed. Second is Richardson number, that we will discuss now. And the third is classification scheme. For example, like after seeing the weather, you can decide whether your chimney emitted smoke or the plume will be rise or will go down to the earth. Okay, so you may decide with the wind velocity or the wind speed or your radiation. So this is all about under this classification scheme. So we will first talk about the lapse rate. Okay, and how this lapse rate will determine our atmospheric stability. If you people have any doubt anywhere, you can raise your hand, you can write in the chat box, you can communicate with me, so that every concept of you people have been cleared by me. Okay, so this was the introduction about the atmospheric stability. So as I told you, the one classification of this atmospheric stability is based on the lapse rate. Okay, and lapse rate is nothing but change in temperature with the height. As we know that in the troposphere, in most of the case, when we go higher, our temperature will decrease. And how much temperature is decreasing per kilometer area in height or the vertically, that will known as the lapse rate. And we have three different type of lapse rate. The first is environment lapse rate. So environment lapse rate is nothing but in the atmosphere, in the current or the ambient atmosphere or the environment, what's the lapse rate? It will change every day, every moment. Okay, this is the first. This is the a very realistic lapse rate of the atmosphere. The second is dry adiabatic lapse rate. This is a theoretical value, and this the value of this is 10 degrees Celsius per kilometer. Means per within 1 kilometer, the temperature will decrease by 10 degrees Celsius, and this is theoretical value. And this value is considered for the air parcel. Okay, when your air parcel is dry in nature, when the relative humidity is not 100%. Okay, then we have the saturated, and we also known as it WALR, or like wet adiabatic lapse rate or the saturated adiabatic lapse rate. So this is nothing when your air parcel, for example, emitted from the chimneys, if your air parcel is 100% saturated, then what will be the lapse rate of that air parcel? And we can calculate it this is again the theoretical value, and the value of this SCLR is 6 degrees Celsius per kilometer. Means per kilometer only 6 degrees Celsius will be reduced. Okay, we have value of DLR, that is 10 degrees Celsius per kilometer. We have the value of SLR, that is 6 degrees Celsius per kilometer. But if we will know the value of this ELR can be any value, because it is changing every day, every second. After after getting this value of ELR, we can compare it with either DLR or SLR, and then we can define whether our air parcel will rise in the atmosphere or will sink down or will be neutral. Okay, so we have divided into six types, six atmospheric stability we have. The first is absolute stability. Absolute stability means your air parcel will not rise vertically, but it will go down. Why it will go down? Because it will be dense, it will be cooler. It means your environmental lapse rate should be lower, and this air parcel lapse rate should be higher. And as I told you, air parcel lapse rate can either be DLR or the SLR. Okay, so here we can see that DLR SLR is greater than this ELR, that is the environmental lapse rate. It means your air parcel is cooling very rapidly as comparison to your atmosphere. That's why it will be dense in nature, and that will sink. And because of its sinking, thus there is a absolute stability condition. Okay, then we have the absolute instability condition. Instability condition means air parcel will rise continuously. And how it will rise? If it will be it will not dense. When it will not dense, when the temperature of this air parcel will be higher as comparison to your environment. And when will this happen? When your ELR value will be higher. For example, your ELR is 10 degrees Celsius per kilometer, means it is cooling rapidly. as comparison to your air parcel. Then if you will compare these two things, then you will get the absolute instability condition. Then we have the conditional stability. This will dependent on whether your air parcel is drier or wetter, and when your ELR is in between this DLR and SLR. We will discuss in next slide as well. And we have neutral, dry, and the extreme. We will discuss in next slide. So yes, so in the troposphere, as you can see, our temperature is decreasing from approximately -15 to -52 degrees Celsius. Our temperature is decreasing with the height, and height is from 0 to 10. Okay, this is nothing but the lapse rate, as you can see. Change in your height per change in your altitude, this is a lapse rate. Okay, and when it is the atmosphere, then we will call it the environmental lapse rate. Okay, so this is what I already have talked. Your air parcel will rise when it will be warmer. Okay, your air parcel will be sinking when it will be the cooler as comparison to your environment or the atmosphere. And your air parcel will neither go up or will go down when the temperature of the environment and the temperature of the air parcel is equivalent. So here we can see this blue color is environment, and we have three parcel, and based on the temperature of the environment and the air parcel, we can define whether our air parcel will go or down. And here I have given this value. ELR can be any value, and for the air parcel lapse rate, this can be dry adiabatic or the wet adiabatic or the saturated adiabatic, and the value is 10 degrees Celsius per kilometer and 6 degrees Celsius per kilometer. So if your air parcel is warmer than the surrounding environment, because your air parcel is warmer, it will be less dense and it will go up. Okay, then this is the unstable condition. In the opposite case, when your environment is warmer but your air parcel is cooler, because your air parcel is cooler, it will be more dense, then it will sink. Okay, then when the air parcel temperature and your atmosphere temperature is same, then this parcel will not move. Then this is known as the neutral layer. If you have any doubt, then you can tell me. Okay, so we have a different type of atmospheric stability. So first we have the absolute stability. As I told you, keep in mind that in right hand side you have the warmer condition, and in the left hand side you have the cooler condition. Okay, and this green color is environmental lapse rate, and you have to compare this ELR, that is the environmental lapse rate, with these two type of lapse rate. One is saturated and one is dry adiabatic. So, and this dry adiabatic and this saturated is for the air parcel, and this environment lapse rate is for the environment. So here we can see that our environment is warmer as comparison to the air parcel. Okay, and we have to see whether our air parcel is cooler or warmer as comparison to the environment. So here we can see our environment lapse rate is, let's say, 5 degree, but our air parcel, that can be either dry adiabatic or saturated adiabatic lapse rate. This can be, for example, 6 and 10 and 6, as we have the value of this theoretically. So as we can see that our air parcel is cooler as comparison to the environment, and whenever it is a cooler, then it will sink down, and this is the case of the absolute stability. Okay, then this is the absolute instability. Instability means your environment is cooler, because here the value is 12 degrees Celsius per kilometer. It is cooling very rapidly. Your environment is cooler as comparison to your air parcel, that can be either 10 to 6. Okay, when your air parcel is warmer, then what will happen? It will go up. and this is known as the absolute instability condition. Then we have a conditional situation when your ELR is in between DLR and SLR. So whether your air parcel is dry in nature or wetter in nature, that will decide your atmospheric stability. In the first case, for example, if your air parcel is dry in nature means your value is 10 degrees Celsius per kilometer. Okay, if your air is drier, then it is cooling rapidly, then it will lead to the stable condition. But if your air parcel is wetter in condition or saturated, then it will lead to the instable. It will go rise, because as comparison to the ELR, the value of this lapse rate is lower for this saturated lapse rate. Okay, so this is the conditional stability based on whether your air parcel is saturated or not. Then it will based on that it will decide the atmospheric stability. Then this is the wet neutral. The 10 degrees Celsius per kilometer is for your dry adiabatic lapse rate, but here we can see that ELR, that is environment lapse rate, is equal to SALR, that is saturated lapse rate. Then what will happen? If your air parcel is saturated, then it will create the stable condition. Then it will create the neutral condition. But in case your air parcel is dry in nature, then we can see that air parcel will cool very rapidly as comparison to the environment, and this again will lead to the stable condition for our dry type of the air parcel. Okay. Then opposite to that, we have the dry neutral. Here we can see that dry adiabatic lapse rate is equal to the environment lapse rate, that is 10 degrees Celsius per kilometer. If our air parcel is dry in nature, then it will create the neutral condition. But in case our air parcel have the moisture in it and have the 100% relative humidity, then it will give you the what type of condition? Here see, this is warmer as comparison to the ELR, then it will give you the unstable condition. Then this is very extreme stability, because this is a very miscellaneous or the anomaly case, when instead of decreasing the temperature with the height, our temperature will increase with this height. So this is nothing but this is the inversion condition, and every time inversion condition will lead to the stability. Means your pollution that has been emitted by any of the chimney will not go up or disperse, but it will go down, and it will lead to the air pollution in the nearby areas. So this is a very this is very dangerous case, and this is known as the extreme stability. So here we can see that our stability, atmospheric stability, is nothing but associated by the temperature. Okay, and our MCQ was only like that. Our atmospheric stability is associated with what? With the vertical temperature. So answer should be 1, as you people already have given me. Okay, so first atmospheric stability was based on the lapse rate. Okay, we can also define our atmospheric stability by another method, that is known as the Richardson number. So based on that formula, if you people can see this Richard formula, based on that we will have some values. Okay, and if this value is more than 0.25, then we will call it is a stable condition. When this value is in between 0 to 0.25, then we will call it is a stable condition. If this value is equal to 0, then we will call it a neutral condition. And if it is in minus, okay, then we will call it the unstable condition. So our classification was on the lapse rate, first thing, and we can also classify this stability based on the Richardson number. And if you will see that your Richardson number is dependent on lapse rate, because here change in the temperature with the change in the height and change in the velocity, wind velocity upon change with the height, and the gravitational value. So on four factor, it is your atmospheric stability has been decided in this classification: your acceleration due to gravity, the temperature change, the height change, and your velocity change. So based on that, you can also classify your atmospheric stability. So this was all about the first MCQ, that was the atmospheric stability, and with which it is associated. It is associated with the vertical height. So I think your MCQ first is clear, and all the information about your first MCQs has been given by me. Okay. The next question is, which of the following factor is associated with the plume properties? So can you give me the answer in the chat box, or you can communicate as well? So can you give me the answer of this question too? We have four options: the wind speed, turbulence, exit velocity, and the atmospheric stability. Alka gave me answer C. Okay. Am I expecting more answers? Jyoti Verma also gave me answer C. Okay, so yes, answer should be C, and Alka and Jyoti gave me right answer. Priyanka also gave me right answer. That is the exit velocity. So if we are talking about the plume, so first we should know what do you mean by plume, then what different properties of plume we have. So let's see. Okay, so here we can see that we have a chimney, and out of that chimney, we are releasing some smoke. Okay, it may be gaseous, it may be solid in nature. So, if we will define this plume, so this is nothing, this is emission or the dispersion and dispersion of the smoke or the vapor resembling a cloud as is spread from its point of the origin. So obviously the definition is very clear. It has been emitted, the first thing. The second thing, it is dispersing. Okay, and what things are dispersing? This may be either smoke or the vapor, and this is just like the cloud, as it will spread from its origin. So this is the definition of the plume. Okay, and a critical relationship exists between atmospheric stability and the pollutant concentration due to its effect on the vertical motion of the air parcel. So how much pollutant it is emitting, with what velocity it is emitting, what is the temperature of the emitted pollutant, what is the diameter of your chimney. So so these type of variable will determine your atmospheric stability and how it will disperse out. Okay, then pollutant that cannot be transported or dispersed into the upper atmosphere quickly become trapped at ground level and pose a significant risk to the human health and environment. This is nothing like, this is just saying that in some cases, if your atmospheric stability is stable in nature means your plume will not go, but will not go up, but will go down, and this condition will lead to the trapping of this pollutant in the nearby area. This will not disperse, and as you can see, like pollution in Delhi, this is because when there is a no wind speed. Okay, if you will not have wind speed, what will happen? Air pollution will not disperse anywhere. It will be stagnant at that position only. Okay, and this will lead to the accumulation of pollutant in that area and lead to the air pollution. So I think plume is cleared. What do you mean by plume? Then this dispersion of this plume is decided by the plume property and the environmental properties. Okay, and plume properties, as I told you, what is the velocity with which your plume has been emitted? Okay, this velocity is known as the exit velocity. Okay, what is the temperature of your pollutant that has been emitted from the chimney? So this is the temperature of the release, or the height of the release. with like what's the height, we will talk about it. Like there is a difference, there is a one height of the chimney, and because of the buoyancy or because of the momentum, your height will be added. Okay, and the sum up of these two height will known as the effective effective stake height. Okay, so the height of the release. So these are the three property of the plume that we have to consider. Then environmental properties, for example, what's the wind speed, what's the turbulence, and what's the atmospheric stability. Based on these factors, dispersion of plume will be decided. Okay, so exactly the answer is, because in that MCQs, this was the answer, exit velocity. I think this is again clear. Come to the question 3. So, a radio sonde equipped with various measuring devices carried up to high altitude by a balloon filled with. So we have to tell the name of that gas with which our balloon is filled. So we have options, that is hydrogen, radon, argon, and nitrogen. So I think one person already have gave me the answer. Priyanka gave me the answer A. I'm expecting more answer from yes, Jyoti Verma also gave me answer A. Okay. Uh, Alka, can you also give me the answer? Okay, Alka already gave me the answer A. And your answer is obviously right. This is A. Because this question is related to the radio sonnet. So, in briefly, we will discuss what do you mean by this radio sonde, what like how we can use this radio sonde, and why we are using this hydrogen gas, why we are not taking this radon, argon, or nitrogen for the filling of the balloon. So let's talk about it more. So if you people have seen this kind of balloons, so this is nothing but the radio sonnet. So here we have balloon that is filled by the hydrogen. Then we have a parachute. Then we have radio sonde. Okay, and this radio sonde is nothing but we have a lot of sensor that has been embedded in it uh, to estimate the temperature, vertically temperature. Like this balloon will be released in the atmosphere, this will go up to the stratosphere, and that will give you the vertical profiling of your temperature, not with temperature but also your pressure, even the wind velocity, and this will also give you the density. So like a lot of sensor has been embedded on it, so that these, and we also have GPS. So this can give you the lat long where it is moving and with which speed it is moving. Such kind of information we can get. So what will happen, like uh, most of the time 3 or 4 times a day we release such kind of balloon, because this balloon has been attached with the sensors, and these sensors will give you the information of temperature and wind and pressure and density. So this will give you the vertical temperature profile. Okay, then this also have the radio signals, and based on that radio signals you will have the graph like this. With the height it will give you the temperature, with the height it will give you the pressure, with the height it will also give you the relative humidity, and with the height it can also give you the vapor pressure, because it have that number of sensors we have that is attached to that balloon. Okay, uh, then we have some advantage and disadvantage of radio sonde. As I told you, like only 3 or 4 times a day we can send this. Okay, and we know that this ELR, that is environment lapse rate, can change every second. Okay, so this is like sometime we can sometime we can get the estimation, but because every time ELR is changing, so it is not possible for us to get the value of ELR every second with the help of this radio sonde, right? Then we have the prawns, that is that data transmitted with very short delay. Okay, you can have data very rapidly because a radio signal will give you data very rapidly. Then it is compatible for measurement in free atmosphere. It is suitable for the climatological studies and data transmitted by international communication network. But it has also some disadvantages. Why? Because it will cross this atmospheric boundary layer within a second or within a minute, so that it will give you only the snapshot of it. Like you will not have the broad picture of it. Then the limited height resolution of the routine extent, because only from 2 to 4 soundings per day at fixed time we will send in the atmosphere. So this was all about the radio sondi. What do you mean by this? What type of sensors we have? Then this balloon and the pros and cons. Okay. So why do we use this hydrogen gas? So we have several reasons for that. This is lightweight in nature. Okay. The second thing is, there is a high lifting capacity. Means for a very low concentration of hydrogen, your lifting capacity will be higher as comparison to the another gases. Then this is also like more available to us as comparison to the another gases. Then if we see the safety consideration, obviously it can lead to the combustion, but if we are taking some safety measurement, then we can confine this safety in our hand. Then environmental impact, as we know that this will not lead to any type of the air pollutant in the atmosphere. So these are basically reason that why we are using this hydrogen gases in the radio sondi balloons. Okay, I think this is again clear to you. Okay, now we have question 4. Which of the following air pollutant is not included in the criteria pollutant? So we have 4 options: the carbon monoxide, carbon dioxide, lead, and the ozone. So Priyanka gave me answer B. Alka also gave me the answer B. Okay, and okay. So the answer should be, obviously you people know the answer. So yes, the answer is carbon dioxide. Jyoti Verma also gave me answer B, and this is right. Answer is a carbon dioxide. So here we have the terminology criteria pollutant. So what do you mean by criteria pollutant? And uh, is is it is varying from country to country, or how many criteria pollutant we have for the India, and what are these? So such kind of for such a type of answers we will try to discuss. uh, okay, then there is a definition of the criteria pollutant. So criteria pollutant refers to a set of pollutant, means we have some number of pollutant identified by some environmental agencies, such as Environment Protection Agency of the USA, or CPCB in India. So the first thing, we have the set of pollutant. We have some number of the pollutant. Second thing, it has been identified some environmental agencies, for example CPCB in India. Okay, and that set of pollutant have some specific criteria or standard for allowable level in the atmosphere. Means these environmental agencies has given some standard. For example, for the sulfur dioxide, the value should not go beyond 50 micrometer per meter cube. Okay, so we are giving the standard. Above that standard, this is the violation of the standard, right? Then this will lead to the adverse impact on human or material or plants or animals. So three things to define the criteria pollutant. We have, the first thing is we have some pollutant, and the standard we have beyond which it will give you the adverse impact, and such type of standards has been created by some environmental agencies, for example CPCB. Okay, so and these values beyond which it will give the adverse effect, this value has been given after a very rigorous research. Okay, so if we are talking about the criteria pollutant in India, then according to NAAQS, can you give me the full form of NAAQS? Someone in the chat box? NAAQS? Because these criteria pollutant has been defined under this NAAQS. That is National Ambient Air Quality Standard. Okay, so we have given some values for 12 different type of pollutant, and these pollutants are the criteria pollutant. And what are these pollutant? These are the particulate matter 10, particulate matter 2.5, nitrogen dioxide, sulfur dioxide, carbon monoxide, ozone, ammonia, lead, benzene, benzopyrene, arsenic, and nickel. It means we have 12 such pollutant, of which CPCB has been given the standard. Beyond that, it will be the violation by that city, and that will lead to the adverse impact. Okay, so if you people can see, carbon dioxide is not among these 12 pollutant. Okay, so these are the criteria pollutant. And because we talked about the standards, what are these value? We should also know this value beyond which there is a violation of the standard. So we have these values. Like these values are for the annual and also for the 24 hours. And one value is for the industrial, residential, rural, and other area, and the second value is for the ecological sensitive areas. Okay, if you people see, for the sulfur dioxide, the range should be, and this is microgram per meter cube. Okay, so this value is 50 and the 80. 50 for annual, 80 for 24 hours. Okay, and this is for the industrial or residential or the rural area. But for the ecological sensitive area, because it is sensitive area, then your value should be less. Your standard, your maximum value for this sulfur dioxide should be lower. Then this is 20 and 80. For the nitrogen dioxide, it is 40-80, and the 30-80. 30-80 is for the ecological sensitive area. For the particulate matter, this is 60-100 and the 60-100. Same values for industrial as well as the ecological sensitive areas. Then for particulate matter 2.5, it is 40-60, and same for the ecological sensitive area 40-60. Then you have value for the ozone 100-180 and the 100-180. For the lead, you have value 0.5, 1 and 0.5 and 1. For the carbon monoxide, 2 and 4. And even for the ecological sensitive area, this is again 2 and 4. For the ammonia, you have 100 and 400. And for the ecologically sensitive areas, we also have the same value, 100 and 400. For the benzene, we have 5 and 5. Here we are not taking the value of the 24 hours measurement. Okay, benzopyrene, we have 1, 1. Arsenic, we have 6, 6. And nickel, we have the 20, 20. So we have some value. If any city is crossing that value, then it will give you some kind of adverse impact. Okay, so these are the criteria pollutant, because we have identified these, and we also have given some standard value for that. Okay, so these are the criteria pollutant. But this is for the India, right? Criteria pollutant for the USA is different. It may be lead is not the part of the criteria pollutant uh, in the USA criteria pollutant list or not. Like, you have to see. But this is just for the India, and has been defined by the CPCB. Okay, because we already have seen that table and the values, I think you people can give me answer very quickly. This is annual national ambient air quality standard, that is NAQS, for sulfur dioxide in microgram per meter cube in industrial, residential, rural, and another area is option we have 50, 60, 70, 80. Alka gave me answer A. Priyanka also gave me answer A. Jyoti gave me answer A. Yes, it is 50. As we can see here, this is 50. Right. And he also gave me the right answer. We already have cleared it. Okay, so the answer is 50. Okay, so this question is related to the air quality index. As you people see, every time, most of the time, like when there is a holiday in Delhi, most of the time your AQI is beyond 400. Okay, so what do you mean by this AQI? And we have question related to this. So here we need to calculate the sub index for the given concentration. So we have particulate matter. So pollutant is particulate matter, of which concentration value is 90 micrometer per meter cube. So the real concentration in the atmosphere is 90. And we also have given four different values. These values are 150, 150. We will see what do you mean by this. And they asked to calculate the sub index. So can you people calculate it, or should I? So this question is related to the air quality index. Can you give me the approximate answer of it? What will be the answer? Okay, don't worry. We will, like, first, Priyanka gave me answer 80. Okay, answer should be 90. And I can, like, see, like, it is not very easy to calculate right now. You may or may not have the pan copy with you, and also you have to calculate it manually with some formula. So yes, I confess that within a milliseconds you can't answer very quickly. So let's see. The answer should be 90. How it is? This question is related to the air quality index. You people know that this air quality index is nothing but we have some number from 0 to 500, and based on that you can tell the people whether your air has been polluted enough or not. And based on that value you can also tell whether this atmospheric scenario is good for you to walk or not, okay, or to go out or not. So if your value is from 0 to 50, then it is good. You people can walk around this, like, there is no harm. Then if you have 50 to 100, then it is moderate. 100 to 150, then it is unhealthy for sensitive group. Then 150 to 200, 200 to 300, 300 to 500. So we have some values, but the question is, from where this value come, how we can calculate this type of values. So basically these value are calculated by some formula, and we have some pollutant of which we can calculate some sub indices, and then after sub indices we can calculate this AQI. So here we can see, uh, to calculate this AQI, we have taken into consideration the 8 major pollutant. Here, particulate matter have the two, PM10 and PM2.5. Okay, so we have uh, particulate matter 10, we have particulate matter 2.5, carbon monoxide, ozone, nitrogen dioxide, sulfur dioxide, ammonia, and lead. So we have 8 pollutant. After taking into that consideration, we will calculate this AQI. Okay, but we have 8 pollutant, right? For that 8 pollutant, we have to calculate the sub-index for particulate matter, sub-index for the carbon monoxide, sub-index for the ozone. Okay, after calculating the sub-index, what we will do, the higher value of that sub-index will be considered as the AQI. For example, the sub-index you have calculated for the particulate matter 10 is 100. Okay, but for the carbon monoxide, it is 50. For the ozone, let's say it is a 30. You can see that the sub-index for the particulate matter 10 is 100. That is higher than this carbon dioxide and carbon monoxide and ozone. Then our AQI will be the maximum value. That maximum value will be the 100. Okay, so Now the question is, how will you calculate that sub index? And that MCQ that I asked is the calculation of the sub index. Okay, so here we have something. So we here we have the formula to calculate the sub index. Here I is the pollutant. This I can be particulate matter. This I can be carbon monoxide or the nitrogen dioxide or the sulfur dioxide. So so this is the formula. Here sub index is equal to IHI minus ILO. uh, H and L, this so we have some values, and this is, if it is the BHI, this is the breakpoint concentration. Means this is the concentration of that particular pollutant, and this is the higher value. Okay, we will see what do you mean by higher value. And if it is the LO, means this is the lower value of the concentration, and this is if it is the IHI, this is the AQI corresponding to that lower concentration, sorry, higher concentration. And if it is the ILO, I will try to this. Here we can see, like, here we can see, like, for the land we have some values for the concentration. Okay, and in the right hand side we have the concentration value of the land, and in the left hand side we have the AQI for this land only. Okay, for example, the first value we have from 0 to 0.5. Okay, so 0 is the lower concentration. Okay, and 0.5 is the higher concentration. Okay, so this is the lower and this is the higher concentration. If we see that the AQI for this range from 0 to 0.5, we have range 0 to 50. So lower AQI will be 0 and higher AQI will be 50. For example, our uh, pollutant concentration is 0.25. So here you can see that 0.5 will come into this first range from 0 to 0.5. Okay, so we will have five value: the concentration of the pollutant, that is 0.25, the lower value of the concentration, the higher value of concentration, the associated AQI, lower value and higher value. If you will see here, so in above we have the AI value for the higher value, higher concentration. We have AQI for the lower concentration. We have the lower concentration and higher concentration. Then CP is the actual pollutant concentration, as I told you, like 0.25. Then by which you can calculate this sub indexes. Okay, so likewise, like this is for the LAD. For the ammonia you have different range and the different associated AQI. So for sulfur dioxide it is different, for nitrogen dioxide it is different, ozone, carbon monoxide, particulate matter. So here I have give you some one example. So here the it was the particulate matter of which we had the concentration 85, and the higher value was the 50, lower value was the 50, sorry, higher value was the 100, lower value was the 50, and the associated AQI for the higher value was the 50, and the lower value of AQI associated with the lower value concentration was the 50. And this is again this concentration. So here we can see, like, this is for the particulate matter. So because our value was ranging, this value is 85. Now our concentration of this particulate matter 10 is 85. So if it is 85, then the range will be 51 to 100. So here the value is 51, lower value, higher value is 100. For the AQI, higher value, lower value is 51 and higher value is 100. But here in this question, these values are 50 and 50, 100, not 51 and 100. So based on that, you will get the answer 85. But if your concentration is 90, as given in the question, so then this 85 will be replaced by the 90, and again you will get the answer 90. I think this is little trickier, but you will understand it later. So you will get the answer 90 by that formula. Okay, the next question. When an air pollution index does not indicate poor air quality, even though concentration of one or more air pollutant may have reached unacceptably high value. This is called, so the answer is maximum operator approach, minimum operator approach, elixing, and the ambiguity. Okay, so some of the people gave me the answer C. Gave me answer C, Sachin C, Nishant C, and Alka C. Okay, and answer should be yes. Answer should be C only. That is elixir. Then, what do you mean by these? So the first terminology is again as it was the question, when when your air quality, when your air pollution does not indicate poor air quality but your concentration is higher. For example, for the ozone, your concentration has reached 300. Okay, but when you are calculating the AQI, then this is not give you the alarming value, and this is telling that this is just the normal situation. This is not the pollution condition in the atmosphere. Then means your pollution is underestimating by this AQI, and this is nothing but this is eclipsing. And why this happen? For example, when you are doing the weighting addition, as we calculated the sub indices now, when you are adding that sub indices with some additive factor or the weighting factor and then summing up all, okay, or you are averaging all the sub index and to give you the AQI, then there will be the condition when there is the underestimation. But if there is the ambiguity, ambiguity is the opposite to that. If pollutant value, if there is not that much pollutant concentration in the atmosphere but your AQI giving you a very higher or the alarming value. Okay, so why this can be happen? This can be happen with the, let's say, the multiplication type of multiplication. For example, if you are multiplying your sub indexes, then it will give you the very higher value. But it may be the condition when your all concentration of all pollutants are within that permissible limit. Okay, so this is nothing but the overestimation, and this situation is known as the ambiguity. And how we can remove it? We can remove it by the maximum operator approach. So as we discussed there now, if we have three value of the sub indices or the four value of sub indices, we will select the maximum value out of this four index. That will give you the ultimate AQI. So this approach, maximum operator approach, can remove this type of conditions or this kind of situation where there is the underestimation or the overestimation. So right now, whenever we are calculating AQI as per the CPCB, so let's say for the 8 pollutant, we have 8 sub index. So out of that 8 sub index, what is the maximum value that will be selected and considered as the AQI, by which you can remove such kind of a situation. Okay, so so this is all about the eclipsing and the ambiguity. Okay, the question is, this is, as per the method adopted by CPCB, if the AQI is 120, then the corresponding air quality rating will be, like what will be the impact if your AQI value is 120? Then we have the option A, minimal impact, B, minor breathing discomfort to sensitive people, C, respiratory, and D is the breathing discomfort. You people gave me, let me see. Alka gave me D option. Priyanka also gave me D option, and obviously you gave me right answer. This is Jyoti also gave me the answer D. So here we have, like we also know that our AQI value ranges from 0 to 500, and if our value is from 0 to 50, then it will cause minimum or no impact on health. if your value is from 51 to 100, then there may be some breathing difficulty in the sensitive groups only. Okay, then if your value is from 101 to 200, then there may be the breathing discomfort for children and the elderly people and the people already suffering from the lung disorder and the disease. And in the question we had what, the AQI was 120, and this 120 will lie between this 101 to 200. Okay, another we have like from 201 to 300. Here the health impact will be on the people when for the when they will be exposed for the longer term, and people already suffering from the heart diseases can experience discomfort for the even shorter exposure as well. If your value is from 301 to 400, this will cause the respiratory illness for a long duration of the exposure. And if your value is from 401 to 500, then this will give you the adverse impact even to the normal people and also to the diseased people. And it also causes severe health impact on the sensitive people. Okay, so this was all about like probable impact that will have based on this AQI range. Okay, so for example, when most of the time when your AQI is more than 400, sometime in the winter's time in the Delhi, so most of the time there is a holiday of school children, uh, so that they do not have such kind of impact. Okay, okay, we have question 9, and question 9 is the trajectory model comes under which of the following air quality modeling classification? And we have option coordinate system, the level of sophistication, the time period, and the pollutant type. Priyanka gave me answer A. Nishant gave me coordinate. Okay, he also gave me the answer A. Alka also gave me answer A. Okay, and obviously you three people. Jyoti also gave me answer A. Every time you gave me answer A, so obviously this is A. So let's talk something about this air quality modeling and its classification. So the first thing is, what do you mean by the air quality modeling? So for example, if you want to know in the future time, if you want to install a chimney in some area, in some populated area, okay, then but before that you have to take the environmental clearance in the means you have to have the clearance by the CPCB. Either this chimney will give you the impact on the population that is nearby or not. Okay, so how will you do that? For example, you have that chimney, and how much pollutant or the emission emitted by this chimney will be dispersed or emitted, or will go up to that target, for example to the populated colony, for example. So how much concentration you will get at the 2 kilometer distance? So how will you calculate it? Okay, this is based on the model. The first thing is that if you want to calculate at some distance, for example at 10 kilometer distance, what will be the impact of that chimney? At the distance of 5 kilometer, what will be the impact of that chimney if we will install that chimney here? Okay, so such type of calculation can be done by this air quality modeling. The second thing is, if you have the concentration value, if you have the sources, like from that sources that much of the pollution will be emitted, then you can forecast like what will be the pollution level within 2 or 3 days next. Okay, so you can forecast with the help of this air quality modeling or the model. So first thing, you will have to give this input data. Input data is emission data. You will give the meteorological data. What will be the wind speed, what will be the temperature, And then you will have to give the topographical data. What's the undulation there, what type of topography we have in that area. Based on that, you can do the forecasting for the next 2 3 days. You can also forecast, if you will install the chimney at that place, what will be the pollutant level or pollutant concentration at some distance. So such kind of things can be done by the air quality modeling. Okay, so based on, like, we have classified these air quality models on different basis. For example, if we are classifying it based on the time period, whether it is giving us a very like monthly data or annually data, or it is giving us the hourly or let's say the daily data. Okay, so for example, if you are giving, if this model is giving you the hourly or the daily data, then this is the short term model. But if this is giving you the average value of the season, or let's say average value of the annual, then these are known as the long term model. Okay, this is based on the time period, like what type of data it will give you. The second is based on the pollutant type. Either your model have that type of computation on which it can calculate the formation of secondary pollutant or not, or it will be non-reactive, like your model will not incorporate the secondary pollutant formation. Okay, when your model is not considering the formation of secondary pollutant, then your model will be non-reactive model. And here pollutant will be like this: particulate matter, sulfur dioxide, or the carbon monoxide. But if your model will be like this, it will consider this primary pollutant and will form will create or doing the formation of the secondary pollutant, such as ozone formation and like this, then we will call this is the reactive model. Okay, this is based on what type of pollutant you are considering and how much capable your model is to compute it. Okay, then uh, based on the coordinate system, we also classified our air quality model. For example, either it is a grid system, grid based, or it is a trajectory. Grid means every like a specific area has been divided into the grids. As we can see, like for example, if you are seeing the map of India has been divided into grids by the latitude and longitude. Okay, this is the horizontally. But vertically, you can also do like this, like from let's say from 0 to 1 kilometer, you have one box. From 1 kilometer to 200, you have second box. To 2 kilometer to 3 kilometer, you have a third box. So vertically as well as the horizontally, you can divide your globe or your earth into the grids, and based on that you can calculate the pollutant concentration in each grid. And even some model you can like these grids can communicate with the neighboring grid. For example, whatever the temperature of this can influence the neighboring grid. Okay, so these grids can communicate with each other with the neighboring grid cells. So this is the grid based. And second is trajectory. So it will follow the plume as it moves downward. So like what will be the direction of the plume and how this will be dispersed. So this is the trajectory. Okay, then fourth, we can divide or the classify this model based on the level of sophistication. Like whenever we have a lots of assumptions in that atmosphere, in that air quality models, to make this very simpler or to make it very conservative, then this is the screening models. When you are not taking into consideration too much assumptions, you are just giving the realistic values, then this will be very refined. For example, sometime what will happen, like uh, if you people know that some of the values we can like how should I let you understand? uh, For example, the wind speed. Wind speed is maybe vary. Okay, and based on the changing wind speed, you may have different value of the dispersion. Okay, but in some of the model, your wind speed value will be constant. It means you are doing the you have some kind of assumptions that your wind speed will not vary but will be constant. So means you are just doing some very rough calculation, and this will provide you only the conservative or the rough estimate. Then this is the screening. But when your model has such type of facilities by which you can give each second varying wind speed, and based on that it will give you the dispersion. Okay, so this is the refined, means there is a more detailed treatment of physical and chemical atmospheric processes, and it require more detailed and precise input data. So based on the sophistication, how simple your model is, you have divided your models into screening and the refined model. So our question was like this one, based on the coordinate system, what type of what type of air quality model we had. So we had the grid based. So answer was the grid based. Okay, the next question, which of the following method is based on the Gaussian model? So we have four different models name. The one is Aurora, the second is Air Mode, the third is GRAL, and the fourth is Atmos. So which one is based on the Gaussian model? So Alka gave me answer B, Priyanka gave me answer B. Okay, and Jyoti also gave me answer B. So let's see what should be the answer. Answer is B. So like here, I will not go into the detail about the air mode model, but I just want to tell you what do you mean by the Gaussian model. So Gaussian model, like Gaussian is nothing but the normal, like the model that will follow the normal distribution of the dispersion will be the Gaussian model. For example, if you have plume, do I have? Okay. For example, if you have plume and this plume is going vertically and spreading uh, horizontally. Okay. So either you're spreading horizontally or the vertically is normally distributed or not, means it should have some peak where you have the maximum concentration. For example, if you know the center line of the plume, that center line has the maximum pollution. Okay, so either your vertically dispersion or your horizontal dispersion, this should be normal, should follow the normal distribution. Then this will be the Gauss. Then such kind of equation will follow the Gaussian model. And one of this Gaussian model example is air mode. And there are some model which are which are following this Gaussian model. This is Galine 4, Highway 2, Car FMI, OS PM, CalPerf, Air Mode, and the ADMS. We will not talk about this different type of dispersion model, but you should know the principle of the dispersion model. Means you will give some input, that input will be related to your chimney, or let's say the source. Then you have the meteorology condition, you have the topography. Based on that, your model will give you the dispersion value, and how much dispersion will happen in the atmosphere based on that values, and at what distance what concentration you will get. So this is the basic principle of your air quality models. So in spite of this Gaussian model, we also have the box model, Langerian and the Eulerian model, and the computational fluid models. And we have given some example of these models. If you people are interested, then you can again explore it further, like what specification we have for that specific model, right? Okay. These were the 10 questions that I took from the previous year's or the last year assignment. And right now we will discuss about the current assignment that has been given to you. But I will not share you the answer because you will solve it. But yes, I will give you some explanation of this MCQs, right? uh, so the first question we have, what critical relationship exists between atmospheric stability and the pollutant concentration in relation to plume? So the MCQs, we have the horizontal motion of the air parcel, vertical motion of the air parcel, atmospheric pressure variance, or the pollutant adhesion to surface. So what do you think? What should be the answer? As we talked about that atmospheric stability, what do you mean by this, and how this is related to the pollutant concentration? So can you give me the answer of this? Priyanka gave me the answer C, Alka gave me answer B. Okay. Okay. Here we had uh, we already, Savita also gave me answer C. Okay. And this is question related to the atmospheric stability and pollutant concentration. Means whether your pollutant will rise or will sink based on the atmospheric stability. So how, what type of motion you will have of the air parcel. So here you can get, like, as I already talked about it, like atmospheric stability is nothing but it is a tendency of air to rise or resist the vertical motion. Okay, whether your air parcel will go up or will go down. Okay, so this is all about the atmospheric stability. So this is vertical motion. So I think you people can give the answer it accordingly. Then we have the question 2. Which of the following plume type exists under the neutral lapse rate when wind speed is greater than 32 km per hour? So we have, like, we already talked about, Nishant gave me answer Conning. Okay, let me see. Alka gave me answer C, again Conning. Okay, so we will discuss different type of plumes we will have in the atmosphere, and what's the impact of wind speed on this plume formation. Okay, here see. Okay, we already talked about plume. We have chimney, and out of that chimney, some cloud-like thing will release or smoke. That smoke or the vapor that will emit from that chimney, and that will disperse. Okay, so this is nothing but the plume. But what type of plume we will have in the atmosphere will be related to your atmospheric condition. So we have 7 different type of plumes that we can find in our atmosphere. This is looping, fanning, conning, lofting, fumigating, trapping, neutral. So let's see. So if it is the looping, okay, in that looping, you will see that your ALR, that is adiabatic lapse rate. This adiabatic lapse rate is for the air parcel. Okay. And this environment lapse rate is for the environment. Okay. If you will see that your air parcel is warmer than your environment because ALR is smaller than the ELR. Okay. So your ALR, that is the air parcel, will be warmer as comparison to the environment. If it is a warmer, then this will be less dense, this will go up. Okay. And there will be, like, this that will give you the very unstable condition. Okay. And that's why there is a this type of condition. Then what will happen? So this is the irregular loop, and this is very unstable condition, unstable condition, and this pollutant may also contact with this ground. So this is the looping. And because you know that whenever there is a in unstable condition means your air will rise vertically, and most of the time this unstable condition is due to the temperature gradient. Means your there is a difference in the temperature. Okay, and because of the maintenance of that temperature gradient, you will have the unstable condition, and that temperature gradient can be maintained only when there is a very low wind speed. Okay, or when there is a very calm condition we have. Otherwise, this temperature gradient will be disturbed. So because this super adiabatic lapse rate is because of the temperature gradient, we have the unstable condition, and that's why the wind is very light, but the thermal turbulence means because of the temperature gradient it is very intense. It can occur during daytime with clear or partial cloud sky or very intense solar heating, again because it will maintain the temperature gradient. And sometimes this dispersion can be happen or may contact with the ground, and that may lead to the some pollution at the ground level. But this is the unstable condition, it will go very rapidly somewhere and will disperse very rapidly. Okay, the second condition we have the fanning. Okay, and here I already talked about ELR, and whenever there is a inversion condition, inversion means temperature is increasing with the height, and whenever this is the condition, just close your eyes and say that this is the stable condition. Okay, whenever there is a inversion means temperature is increasing with height, then there is a stability. Stability means uh, the your air pollutant will not disperse. Okay, and if it is not dispersing, you can see that your air pollutant that has been emitted by the chimney is not mixing with the atmospheric gases and follow a very sharp line, sharp horizontal line. So this is the narrow horizontal fan, that's why this is fanning condition. There is no vertical spreading for kilometer downward. Why? Because it's the inversion condition. Inversion means very stable condition. Okay, and here we will have the light wind and the very little turbulence, and this will occur at night and in early morning, because whenever you have the inversion condition will happen only in the night time most of the time. Okay, why? Because uh, air air near to the ground will cool very rapidly as comparison to the air that is above the atmosphere, above that ground. Okay, because of that the temperature near the ground will be low, but at the higher height you will have the higher temperature. So this is the inversion. With the height, the temperature will be increasing. So this happen mostly in the night time or in the winter's time. Okay, so this is typically occurs at night and in early morning, and in any season, usually favored by the light winds. And here we can see this will not go down most of the time. Okay, so this is the fanning condition. Then we have the coning, as you people gave me the answer. You people gave me the coning. So coning is nothing when your air lapse rate or the environment lapse rate is equivalent to the your air parcel lapse rate. Okay, so what will be, there will be a very neutral condition. So uh, here we will have the cone shape horizontal axis dissipate further downward than the looping flow, and this is the neutral condition because here the environmental lapse rate is equal to, approximately is equal to the adiabatic lapse rate. And again here wind speed is 32 kilometer per hour. Then the associated wind and turbulence here, whenever we are going from unstable condition to neutral to stable condition, our wind speed will increase. So here we can see that our wind is moderate to strong and turbulence is largely mechanical rather than thermal. We will talk about it. What do you mean by mechanical? Whenever there is a like topography is uneven. Okay, there is a mountain, there is a sea, because of that there will be some kind of turbulence or the changes in the wind speed, changes in the pressure, changes in the temperature as comparison to the thermal. Thermal is the temperature gradient. Whenever there is a temperature gradient, you may have the difference in your variable. This also cause the turbulence. So here the turbulence is largely because of mechanical but not due to the thermal condition. And here typically it is during the windy condition, day or night, and there may be like cloudiness in that day, that will favor this type of the plume type. Okay. And here disperse less rapidly with the distance and large probability of ground contact. So this will come to the ground. There is a higher chance of it. Okay. Then we have the lofting condition. In the lofting, here we can see ELR had the inversion condition initially, means temperature was increasing with the height and then it decreased with the height. So up to that, up to the inversion condition, you will have the stable condition. Stable means no mixing. So you can see that at some height there is a no mixing, but after some height there is the mixing. Means there is the inversion below and there is the unstable condition above. Okay. So this is there is a well defined bottom, because this will not mix, because there is the inversion condition. And this I already have covered. Then the winds, there will be moderate wind with considerable turbulence aloft and a very light wind or little turbulence in the layer below. And this will occur typically like during changes from lapse to inversion condition. When there will be some scenario whenever your lapse rate is converting into the inversion condition, so then this type of plume type may be happen, and usually near sunset or fair days. And there is a very small probability that it will come to the ground, because as you know that there is a inversion condition near to the stack or near to the ground. So if there is an inversion condition, means stability means no mixing in the near to the ground area. So this is condition very favorable, like very favorable in the means of uh, pollutant will not come to the ground in any case. So this is very favorable condition for us to have this condition. Then the fumigation. Above stack or above some height, we have the inversion. Means there will be no mixing after some height, but but here we have a very unstable condition near to the ground. If there is the unstable condition near to the ground, means there will be more mixing near to the ground. So this is very dangerous, like your pollutant will not go up but will come down to the down to the ground surface. Okay. This is the most dangerous condition in the plume type. This is fumigation. And because there is a unstable condition in the lower level, but at the higher level there is a neutral condition, means no mixing. No mixing can be happen at some distance, but near to the surface there will be the mixing. So all the pollutant that has been emitted by the chimney will go downward only. So this is the aloft inversion, like inversion to the aloft condition. Uh, then associated wind and turbulence. Here wind will be light to moderate, and there will be thermal turbulence in the lower level and little turbulence in the upper level. Then typical occurrence will be when during there will be change from inversion to the lapse condition as opposite to the aloft condition, and may occur when there is a sea breeze in the late morning or the early afternoon, and there is a very high chance that pollutant will come to the ground and will give you the stagnant condition where most of the pollutant will be accumulated near to the ground. Then this is the trapping. This is like here you can see that initially we had the inversion condition. Inversion means stability means no mixing. So no mixing near the ground. Okay. Then we will then pollutant will be mixed. Then again the ELR is inversing, like there is a inversion condition of the ELR. Again, there will be the stable condition and no mixing. Means there will be the definite height upon which mixing can be happened, but there will be no mixing at the bottom or in the top. So this is the trapping. Pollutant has been trapped in some layer. So this is the trapping condition. So there is the unstable condition between two stable layer at the top and at the bottom, and in between that you have the unstable condition. And you know that in only unstable condition there is the mixing. So this is the trapping condition. So here you will have light wind, will have thermal turbulence in middle trapped layer, and there will be no turbulence in below and the upper layer. And if we will talk about the typical occurrence, then during clear sunny days or clear night with light winds, you will have such kind of condition, and it will disperse very slowly because it has been trapped. Okay, and concentration is very high, and low probability of ground contact because there is a inversion condition near to the ground. So there will be very low probability that your pollutant will come to the ground level. Okay, the third question is, what is the property of the plume that influences the dispersion of air pollutant? And the option we have wind speed, second is exit velocity, the third is atmospheric stability, and fourth is turbulence. Nishant gave me answer D, turbulence. But Priyanka gave me answer B, exit velocity. You have to keep in mind that you are talking about the property of the plume. Okay, you are not talking about the property of the atmosphere or the meteorological condition. And the property of plume are nothing but means a property of plume will have, for example, the increase the temperature, what temperature we have of that plume, what velocity with which this plume is emitted, this is also known as the exit velocity. Then what will be the concentration of that plume, then what should be the stack diameter. So such type of property will come under this property of the plume. So I think the answer that is turbulence. You have to consider why this is not the turbulence but something else. Okay, the turbulence is not the answer because we are talking about the property of the plume. Okay, and property of plume will be like this: your velocity with which plume is emitted, the temperature of your plume, the height of that plume, and even the concentration of the plume. So these are the property of the plume. So you will have to see what option you may have. Okay, here we had no plume property, then we had the option exit velocity, then the temperature of the release and the height of the release, and even the concentration of the plume. So these are the plume properties. Okay, then by which you can give the answer rightly. Okay. Okay, then the question we have: turbulence consists of irregular swirls of motion of wind that are known as, I have answer, uniform wind pattern, wind direction, eddies, and the atmospheric stability. Alka gave me C answer, and Nishant gave me C answer. Priyanka gave me B answer. Okay. Uh, okay. The first thing that you have to keep in mind, what do you mean by the turbulence? So I gave you, okay, Savita gave me answer B. So turbulence is nothing but it is like irregular motion of the air. Okay, irregular means whenever your wind is going like this, it may rotate, it may go down, or the speed can be very higher at a moment, or speed may be lower at a moment. So like a very irregular behavior of the motion of the air. So this is turbulence. and and here you can see like this may change the direction of the wind, this may change the speed of the wind. There is a irregular swirl of the motion, and these are known as the eddies. Okay, note another term. So here you can see what can be the right answer. And this turbulence may be caused by different things. I will show you. Okay, this turbulence may be generated by different type of forces. The first is the solar heating. When there is a thermal contrast, for example, at one place there is a high temperature, at another place there is a lower temperature. Then when these two temperature will come in contact, or the air of that two temperature will come into the contact, there will be the turbulence, or the irregular motion of the wind, or the irregular motion of the air, because of the solar heating or because of the temperature gradient. So this is the solar heating. The second is frictional drag. So for example, you have mountain, you have plain area, you have lake, okay, you have buildings. So whenever your air will strike to mountain, let's say it will strike to the building, your air direction, your air speed will change, or I will not say air, your wind speed, okay, or the wind speed or the wind direction will change. Means it will lead to the irregular motion of your air. Okay, so this is the frictional drag, or you can also call it is a mechanical turbulence. Then sorry, this was the part of the obstacle. Okay, uh, so whatever I was talking about, this whenever there is a building or lake, or let's say forest or topography, mountain, whenever there is a deflection of this flow or the changing in the flow, then this will come under the mechanical force or the obstacle. But if we are talking about the frictional drag, then this is because of the wind shear. Wind shear means there is a different speed and direction of the air at the different places, and when that wind will contact with each other, this will give you the frictional drag. Okay, so whenever different temperature air will come into the contact and will give you the turbulence, that this is the first type. When you have different speed and different direction of the air, and that will come in contact and will give you the turbulence, that is the frictional drag. And when there is a mountain and something like that, and when this obstacle, when your air or the wind will strike to that obstacle and will give you the turbulence, that will come under this obstacles. Okay, so by these three forces, you may have the turbulence at the boundary layer. Okay, and whenever there is a like small eddies means irregular. Here you can see like here in the figure you can see like there is a changing in the direction of the wind. Then these are nothing but the eddies. Okay, the question 5. What does the mixing height determine in relation to pollutant? So option we have wind direction, the volume of atmosphere available for dispersion, third is atmospheric temperature, and D is the solar radiation level. What do you think? What should be the right answer? A, B, C, D about the mixing height. What does mixing height determine? Priyanka gave me the answer D. Alka gave me answer B. Okay. Uh, First, you have to understand what do you mean by mixing height. Mixing height is nothing but the height beyond which there may be dispersion can be happen. Like for example, up to 2 kilometer, pollutant can be dispersed, but beyond that 2 kilometer, pollutant will not disperse. So from my this statement, you can define the right answer. Okay, so mixing height is the height of the layer in which pollutant or any constituent emitted or entrained into it are the vertically dispersed due to the turbulence. Like this is the height upon which dispersion can be happen. The only thing. So it will define in what area or in what volume your air can be dispersed. So this will give you the limit on the area. So it determines the volume of the atmosphere available for the dispersion of pollutant. And this is very important. Your mixing height should be higher always. Whenever it is not higher, means your pollutant will be near, every time it will be near to your ground. Okay, whenever your mixing height is like 3 kilometer, 4 kilometer, 5 kilometer, means your pollutant will go in the upper level and can disperse, means the pollutant concentration near to the ground will be diluted. uh, Mixing height is very much related to the dilution. There will be more dilution if your mixing height is more, means the area for the mixing of your air pollutant will be higher. And this will lead to the dilution of your pollutant, right? So this, based on that, you can give the answer. Next is, why is air monitoring uh, carried out in places of high natural environmental values? So the options I have: to assess natural disaster, to evaluate urbanization, to understand population density, and to preserve natural ecosystem. So what should be the answer? Priyanka gave me answer A. Okay. More answer I'm expecting. Why do we carry air monitoring near to a very natural environment value? Like where there is a very purified air, or where there is a no contamination, at that place we will do the monitoring. Why? Okay, Alka gave me answer D, Jyoti gave me answer D. Okay, let's see. So the area for monitoring can be determined based on, like, the emission source, maybe based on the meteorology, maybe based on topography, maybe based on geography, maybe based on pollution center, historical monitoring data, and the air with high natural environment values. So, for example, you have some park or the forest, or let's say wetland. So, in that area, there is a very purify air. Okay, there is not that much pollutant that we have in the urban area. And monitoring at that area, for example in the national park, is very important, because the biodiversity we have that in that national park is very sensitive to the changes in the pollution level. Okay, so whenever there is the change, or there is a higher pollution concentration in that area, in that a very sensitive area, then you can say that something bad is happening at that area, and you must you should have the air monitoring in that natural environment, because this natural environment is giving the survival of the biodiversity. And if there is a higher level of that air pollutant in that natural environment, that will lead to the adverse impact on the biodiversity. So you must have the values of air in that natural environment as well. So I think based on this slide, you can give the answer of this. Most of you people gave me the right answer. Okay. Then the question 7: what type of monitoring are included in the air quality monitoring network in India? Uh, Alka, uh, here you can see that. uh, why you are carrying out the air monitoring in a very high natural environment value, because you want to preserve your natural ecosystem. Okay, because natural ecosystem have very pure air, and you must have air monitoring in that area always. Okay, if there is a pollutant level higher in that area, that will impact on your biodiversity. So in spite of, like, you have air monitoring in the urban area for the populated people. Okay, for the populated colonies, or for example, what type of impact it will have of the urbanization on the market. Okay, so based on that, you must have data of the industrial areas. Wherever you have the companies, you have the industries. Based on that, because this will have some influence of the on the colonies, on the people. Okay, but whenever you are talking about the biodiversity, and you know that biodiversity are only in the, like, in the forest area, in the national park, in the sanctuaries, then how will you determine the impact of the air pollution on that area? So you must have monitoring in the high natural environment as well. So the answer should be obviously as you given. Okay, the question 7. What type of monitoring are included in the air quality monitoring network in India? So we do two type of monitoring in India, and the answer here is online monitoring. The second is manual monitoring, and third is both online and manual monitoring, and D is the periodic monitoring. Alka gave me answer C. Priyanka gave me answer C. Okay, so in India, we mostly do two type of monitoring. The one is manual. Manual means you have to collect the data, you have to analyze the data, you have to do the sampling. So everything you have to do manually. So such type of monitoring is also happen in India. And the second is automatic monitoring. Means you do not need to do the sampling, you do not need to do uh, the analyzing and publishing the data. It will, like, automatically you can monitor your air pollutant. So this is the automatic, and India does this both type of manual and as well as the automatic. So for the manual, we have, like, different method has been adopted for different type of estimation of air pollutant. For example, uh, for sulfur dioxide estimation, we use improved West and Geiger method. Okay, for nitrogen dioxide we use the Jacob method. For for this ozone we use the chemical method. For the ammonia, we use the endophenol method. For the particulate matter, we use the gravimetric method. For the benzene, we use the absorption deabsorption followed by the gas chromatography. For benzopyrene, we use this HPLC. For for nickel and lead, we use the AAS after sampling using EPM 2000 EDX XRF. And for the arsenic, we use the last method. So these are the manual method. You have to do the sampling, you have to analyze it, and so this is the manual monitoring, where you should have the manpower. But for the automatic, for example, for the sulfur dioxide, we have the UV fluorescence method, in which there is no need of sampling. Everything will be happened automatically. Okay, there is no need of the manpower. For the nitrogen or the ammonia, you will use the chemiluminescence. For ozone, you will use the UV photometric method. For the carbon monoxide, you will use the NDISM method, or this is also known as NDIR. Then for the particulate matter, you will use the TOEM. And for the benzene or for the volatile organic matter, you will use the gas chromatography. Okay, so these are the automatic monitoring methods. So I think India does both manual as well as the automatic monitoring. Okay, this question is again related to the AQI and the eclipsing. So when does eclipsing occur in the context of air pollution indices? So when pollution is overestimated, when concentration of pollutant are within acceptable limit, when pollution is underestimated, and when historical data is missing. Yes, gave. Okay, let me see. Alka gave me answer C. Priyanka gave me answer A. Uh, Let me tell you that we have two terminology. Nishant gave me answer C. Okay, so we had two type of condition while calculating the AQI. The first condition was when when what was that? When your air pollution is higher but AQI value is low, means your AQI is underestimated, and this is known as the eclipsing. Okay, the second condition was when AQI was giving you the false alarm. when your all concentration was in the permittable limit, but AQI is higher, then it is the overestimation, and this is known as the ambiguity. Okay, so I think ellipsing was the first case, and this when will be this case when you are underestimating the pollution, as we already have discussed this earlier. Okay, what type of air quality model deal with pollutant like particulate matter, sulfur dioxide, and carbon monoxide? So we have four options: reactive model, long-term model, non-reactive model, and the trajectory model. Alka gave me C answer, non-reactive. Okay, Priyanka also gave me C answer. Um, okay, so we classified our model on various things, right? Uh, First, based on what type of pollutant we are considering. So, whenever we are considering the primary pollutant, then this will be the non-reactive model. But whenever our model is incorporating the formation of secondary pollutant, for example, ozone formation, then this will be the reactive pollutant. Okay, when your model is giving you the annual value or for the seasonal value, then this will be the long term model. For example, for the whole season, for the winter, if it is giving you the average value, then this is the long term model. And trajectory model, when you have the trajectory or the direction of the plume you will get, then this is the trajectory model. So in that question we have the primary pollutant, and we are not considering the secondary pollutant formation. So this will be the non-reactive model, right? And you people gave me the right answer. Okay, this is the last question. How are screening models characterized in terms of their complexity and input data requirement? So the first is detailed treatment of physical and chemical atmospheric processes. The second is simple estimation with worst case meteorological condition. The third is complex estimation with worst case meteorological condition. And fourth is trajectory based calculation. And let me see who gave me the answer. Um, Alka gave me B option. Okay. Yes. So I think yes, this is right. Okay, so we had two type of model based on the level of the sophistication. How much simplification we have done in our model. As I gave you, like we had two type of model based on the sophistication. One is screening model, and second was the refined model. Screening model means when you are doing a lot of assumption to make your model very simplified, means you are having the conservative approach, because you are doing assumption a lot. You are taking the value of the most of the variable are very constant. Okay, so this is the screening model. Okay, and refined model means whenever there is a very little assumption. For example, I told you, like whenever wind speed the speed of the plume is constant, we are assuming, then this is the simpler one. This is the screening model. But whenever we are considering the changing in the plume speed, okay, with the height, or let's say with the distance, then this will be very complicated, and you must have very good data for that input. You must have very good input for that. Then this will be the refined model. So if we are taking the first option, that detailed treatment of physical and chemical atmospheric processes, then this will be the refined model. Okay, if we are taking the example of second, simple estimation with worst case meteorological condition, then this will be the screening model. If we are taking this third, complex estimation with worst case meteorological condition, this is not happening, this is not possible. Why? If we are considering the worst case meteorological condition, then uh, this will be the simpler estimation, because if it is a worst case, means you are assuming a lot of things. So this is not the possible answer. And the trajectory based calculation, this is nothing but the direction of the flow you can calculate with some model. This is the trajectory based. So this is also note the answer. So exactly the answer should be B. I think this has been done. So I think all of the queries related to your assignment has been clarified. If you have any question, you can write in the chat box. I can discuss it with you. You people can also suggest me how should I teach, or what should I do more to make this course very interesting. And again, because every time this course will be from 6 to 8, and I will take your like this assignment assignment solution based session, then any suggestion or any query is welcome. You can write in the chat box. You can even speak. I will encourage you people to speak. So any suggestion or any query you have, then you can write in the chat box as well. Otherwise, our session is ended here. You people can leave. If you have any question, then you can write. Yes, yes, please, Priyanka. Sixth का D option ही है ना. Okay, let me go to the sixth. Are you talking about this? Yes, answer D is right. Yes, yes. Any more queries? Yes, yes. You can access this PPT. I think NPTEL has given you the link of that folder where we keep these kind of PPTs, so you can access this. I think where there is a course, air pollution and control, you will go down, you will scroll down, then you will get the link for this PPTs. So you can get from there only. And even like there will be the link of this video, then you can watch it even later. मेन एग्जाम में एमसीक्यू टाइप ही क्वेश्चन होंगे कि आंसर क्वेश्चन आंसर इन लॉन्ग. I don't know the exact answer, Karila, but I think like we must have no, we will have the long question answer type as well. This is not that you will have the MCQ type only. MCQ type is only for the assignment, but for this long type, you may have you may have the long type answer as well. But I will clarify it. Alka is saying that this is the MCQ type. I will clarify. I don't think that it will be only based on the MCQ, but yes, but I don't know the exact answer. In next session, I will try to give you the answer of it, whether it will be the long, long answer type question or it will be the MCQs. I will try to. I don't know exactly. Yeah, okay, Alka is giving that MCQ ही होते हैं exam में. Okay, then because I don't know, then yes, it may be that only MCQs will be asked in your exam. Thank you, Alka, for giving the answer of the Karela, because I don't know the exact answer. But thanks for confirming. If you have any query, more query, you can tell me. Ma'am, how do we submit the assignment? There is a click button, like you have 10 assignment question, then you will click on that which one you assume that it is right. Then then there is a button, submit assignment. Then you will click on that submit assignment button. Then your assignment will be submitted. So on the NPTEL, in the course air pollution and control, you have 3 or 4 tabs. In one tab you will have the videos of the lecture. In the second tab you will have the assignment for the week 3. Then you will go to the assignment for the week 3. In that you will have that. And what if we will have not submit any assignment for the previous week? Can we do all assignment at one go? Exactly, there is a particular deadline for that particular week. For example, I don't know what is the deadline for this week you may check, either you can do right now the assignment for the week 2 or not, but for the assignment 3 you still have the deadline. So according to deadline you have to do this. Okay, Nishant told me that for the week 3, 14 fab is the deadline. So up to 14 fab you can submit your week 3, but I don't think that still you have deadline for the week 1 or week 2 assignment. So based on that deadline you have to submit your assignment. So if you haven't done for the first or two, then skip it. But you have to skip it, Jyoti, for this 1 week and two, because deadline you have crossed the deadline. But for the week you can do, because there is a particular deadline for every week assignment. So you have to check like what's the deadline for that week. If you have crossed, then next from third to fourth, every assignment next from first or second you can do. Okay, okay, Jyoti, any another questions you have? Otherwise you people can leave. Thank you so much to be there, to be very patient listening. Okay, when will today's PPT will available, ma'am? Right now it is available on that NPTEL, because the folder that I have shared, in that folder only I prepared that slide. Even right now you can access that folder and this PPT, but for the video you have to wait for 1 day or 2 days till I will upload it. Okay, right now even you can get this video, this PPT from that link, from that shared folder link. Okay, Nishant, thank you so much. Okay, I think if you people do not have any query, then you people can leave. Okay, good night. We will meet you soon on Monday, next Monday from 6 to 8, the same timing. And we will again, we'll have some questions and we will discuss. Okay, thank you. Thank you so much. Okay, Priyanka, you want to say something? Okay, what's the question you have? I will wait. Thank you. Thank you so much, Sweta. Okay, Priyanka have left, so I think she doesn't have any query. Okay, bye bye.
हेलो अलका। अम, हेलो। मुझे एक क्वेरी है, मैं आपको पूछ सकती हूँ अबाउट द एग्जाम फॉर्म? यस, एग्जाम फॉर्म में व्हाट इज द रोल लिखा है हुआ ना, एग्जाम फॉर्म में हमें फिलअप करना है। तो वो मैं अभी ड्यूटी कर रही हूँ एज असिस्टेंट प्रोफेसर। तो मुझे उसमें फैकल्टी लिखना है, मेंशन करना है, या स्टूडेंट? क्योंकि मैं ये कोर्स है वो पीएचडी के लिए कर रही हूँ, पीएचडी के क्रेडिट के लिए, और मुझे सर्टिफिकेट चाहिए फॉर क्रेडिट। सो आई हैव क्वेश्चन अबाउट कि मैं एज ए ये कोर्स के लिए तो एज ए स्टूडेंट हूँ, बट मैं अभी वर्क कर रही हूँ, तो उसमें मेरे को क्या आएगा, एज ए फैकल्टी और स्टूडेंट? ओके, थैंक यू।
Alka, are you there? Yes. अलका, अगर हम लोग के फर्स्ट 2 वीक के मिस हो गए हैं और वीक 3 का भी मिस हो गया असाइनमेंट, तो कुछ प्रॉब्लम होगा क्या? मतलब उसमें कुछ इफेक्ट होता है क्या आगे जाके? क्योंकि मैंने लेट ज्वाइन किया है, तो हाउ इट विल इम्पैक्ट माय क्रेडिट?
नहीं, बस केवल मिनिमम स्कोर चाहिए, 10% काउंट होंगे 25 में से।
तो अब जो मिस हो गए उनके तो काउंट नहीं होंगे ना यार फिर।
लेकिन मिनिमम 10 हो जाए, बाद में बेस्ट आर्ट देखते हैं, 12 असाइनमेंट होते हैं, उसमें से बेस्ट आर्ट देखेंगे।
बेस्ट आर्ट देखेंगे।
हाँ, उसमें से 25 में से 10% जुड़ेंगे केवल।
अच्छा ठीक है, तो यानी कि करते जाए, अभी जो छूट गया वो छूट गया टाइप्स है ना। मेरे तो 3 वीक्स का छूट गया यार, अभी तो 4th वीक हो
बस
गया ना।
8 असाइनमेंट में अच्छे स्कोर लिया और इसका तो हो जाएंगे। तो
अच्छा
मतलब
नेक्स्ट असाइनमेंट
अगर
में।
8 असाइनमेंट फुल भी लगे तो पूरे 25 मिल जाएंगे पूरे।
ओके ओके डियर, थैंक यू वेरी मच काका, थैंक यू, टेक केयर।
कोई नहीं, सेम टू
ओके
यू।
टेक केयर, बाय।